To continue our learning target on ionic compounds, we need to talk about the metals that are in the middle of the periodic table, or the transition metal family. But first, we're going to find a different colored highlighter than what we used before, and you're going to turn to your ionic or covalent flow chart. And we're going to highlight a different colored pathway. So we'll start at our general question, what types of elements are present, and the question would be answered by metal and nonmetal. And then if we see a Roman numeral after the cation name, we would take the left-hand path. And that means we're dealing with a type 2 ionic compound. After that step, the pathways would remain the same, which indicates that the processes are similar except for the step that is indicated by a Roman numeral. Using the same color in your portfolio, find the note sheet that's labeled Naming and Writing Compounds with Transition Metals, Type 2. This green pathway and this note sheet will go together. So transition metals found in the middle of the periodic table are elements that can vary in how many valence electrons that they have. So in order for scientists to classify this information, they use Roman numerals to explain its oxidation number or charge. So in other words, the Roman numeral is equal to the positive charge of the transition metal. But in order to determine the charge of a transition metal cation, we have to know what the Roman numerals look like. A number 1 will look like a capital I, while a number 2 will be 2 I's put together. The Roman numeral 3 are 3 I's put together. A Roman numeral 4 is IV. And the reason for that is that 5 is a V, so 4 says 1 before V, or 1 before 5, which would mean 4. 6, we're going to have VI, so 1 after 5, which means 6. For 7, VII, which means 5 and then 2 more. 8 is the VIII, so 3 I's after V, which means 5 plus 3 more. And the pattern breaks again at 9, and it's IX. 10 means X, so 1 before 10, or IX, means 9. In order to create neutral ionic formulas from a name, we have to be cognizant of what we know and what we're given. Our first step is to look up the oxidation number for the anion, or the nonmetal. So in this case, in our first example, I have oxide, and oxide stands for oxygen. And oxygen is in a family where the oxidation number is defined. So after looking at the front side of my periodic table, I see that it's -2. There's a note here that says the cation or the metal should be indicated by Roman numerals. This is true. So I see that I have iron 3, so that means Fe plus 3. And I knew it was a 3 because there were 3 I's in a row. So because these numbers are not the same, I'm going to have to crisscross. I'm going to pull the 3 down. I'm going to pull the 2 up. So now these numbers that I'm currently highlighting in green represent the subscripts of my formula. So it'll be Fe2O3. Let's do another example together. So I'm going to write my sulfide. Well, sulfide stands for sulfur, and I have to look up that oxidation number, and it's -2. My cation, which is copper, is Cu, and then I see that I have a Roman numeral 2 here, which means my copper that I'm dealing with is +2. I'm going to pull each number down, but then realize that they're the same number, so I can reduce this down to 1. So my formula, because my cation always comes first, is Cu1S1. In our third example, I see that I have oxide again. So I know that the symbol for oxide or oxygen is O. My oxidation number, after looking it up on the front side of my periodic table, is -2. But then I have an unfamiliar element as my cation. I have vanadium. And this is a Roman numeral, but it also, in this particular case, represents the element symbol for vanadium. So vanadium is a capital V, but because this is our Roman numeral, that means this is a +5 charge. So because 5 and 2 are definitely not the same number, I'm going to have to crisscross them. And I'm going to pull the 2 up, and I'm going to pull the 5 down. So my chemical formula is going to be V2O5. For number 4, we're going to replace what's there with cobalt 2 chloride. The symbol for chloride, or in its neutral form, chlorine, is Cl. And after looking at the front side of my periodic table, I see that it has an oxidation number of -1. Cobalt, which has a symbol of CO, has a Roman numeral 2 after it, so its charge is +2. Because these are not the same number with opposite charges, I'm going to have to crisscross the numbers. So the 1 comes up here, and the 2 gets dragged down. So because my cation, or my positive atom, always comes first, I'm going to put cobalt first in my formula with a 1, and then Cl2. On the other side of the note sheet, we're going to go in the opposite direction. So it's important to note that this is a process that with practice you will understand. So the 9 steps for determining the charge of an unfixed cation or a transition metal are specified in your note sheet, and that's something that you're going to put in this box of your flowchart. Our first step when given a formula, but I need to find the name, is to write the name with empty parentheses. So Fe stands for iron, and then I'll write empty parentheses around it. And then O stands for oxygen, but in a chemical formula, we'll change that to oxide, just like we did for type 1 elements. What is my anion? It's oxygen. And after referencing the front side of my periodic table, the charge is -2. According to my formula, I only have 1 oxygen, because there's no number listed there. The next question asks, what is my total negative charge? So I'm going to take the number of atoms, and I'm going to multiply it by -2, because that's the charge of my anion. So I drug the number of atoms down from step 3 and the charge down from step 2. So I have a total negative charge of -2. Because ionic compounds have to be neutral, that means my total positive charge is going to be the opposite. So my total positive charge has to be +2. According to my formula, it's FeO, which means I only have 1 atom of iron. So in order to find the charge of the metal, we're going to have to take my total positive charge, so I'm going to drag that down from step 5, and I'm going to divide it by the number of atoms I have of iron, which is my cation, because it's a metal, which is 1. So my total positive charge, 2, divided by the fact that I only have 1 atom, means that the charge of this particular atom of iron is +2. So the Roman numeral for 2 is the 2 i's put together. And so the name of this would be iron 2 oxide. Now what I recommend doing is pausing and rewinding the video and watching these 9 steps again before you attempt example 2 on your own. At the bottom of the second page, you're going to see some guided practice. We are going to do the first 2 of each together, but the last 3 of each you should try on your own. So looking at chromium 2 sulfide, the symbol for chromium is Cr, and this Roman numeral 2 means I have a +2 charge. Sulfide stands for sulfur, and that's in a family with a defined oxidation number, so it has a charge of -2. Because these are the same number with opposite charges, I'm going to leave this alone, so my formula is CRS. Looking at zinc 2 chloride, our next example, the symbol for zinc is Zn. This Roman numeral 2 means it's a +2 charge. Chloride, the ion form of chlorine symbol, is Cl. And after looking at the front side of my periodic table, I see that it has a -1 charge. Because these are not the same number with opposite charges, I'm going to have to crisscross the numbers down to make subscripts. So my new formula is Zn1Cl2. For the bottom half, we're going from formula to name. So because we have a metal and a nonmetal, I'm going to first write the full name of the cation, which in my first example is iron. And then I'm going to write empty parentheses after it, and then I'm going to put oxide. In order to find out what goes in these parentheses, I'm going to reference the 9 steps that are in my notes and that I've rewritten on my flowchart. So oxygen has a charge of -2, and there are 3 of them, which means I have a total negative charge of -6. This means that my positive charge has to be equal to +6 because ionic compounds are neutral. We're up here, sorry guys. According to my formula, I only have 2 atoms, so I have to take that +6 charge and divide it in half because I have 2 atoms. So that means each atom of iron has a +3 charge, and the Roman numeral for 3 is 3 lines next to each other. For CDO, I'm going to follow the same procedure. I'm first going to write the full name of the of the cation with parentheses after it, and then write the back half of it, oxide, using the ID ending because it's a front side element. In order to find the Roman numeral that goes in the middle, I have to follow the 9 steps as laid out in my notes. Oxygen has a -2 charge, and according to my formula, I only have 1 of them. So it means I have an overall negative charge of -2. That means that I have to have a +2 charge because ionic compounds are neutral. According to my formula, I only have 1 of them. So I'm going to take that total positive charge and divide it by the number of cations I have, which equals +2. So this atom of cadmium has a charge of +2. And the Roman numeral for 2 are 2 lines next to each other. Now I understand that this is a difficult concept, but with lots of practice, I know that you guys can understand this easily and quickly. By putting in the work now, by putting in the effort, you're setting yourself up for success in criteria 4.2 and in 4.4, which is a combination of ionic and covalent compounds.